Hi folks, welcome to another Wednesday Widget by NYC CNC. Today we're going to be working with a set of Softjaws. We're going to do a typical run through. We're going to build them in SolidWorks, hop over into SprutCAM and lay out our toolpaths, and then we're going to go over onto the Tormach and machine them up. So by all means, it's going to be a lesson on the usual design and machining elements. It's also going to be a lesson on a mistake I made, which is I published a video that you can see here a few months ago trying to do the same thing, which was this first shot was an aluminum part where I machined out these pockets and threads and then ripped it, a split line in it with a bandsaw and tried to clamp down on it, and it didn't work. In fact, it was a poor design and it was over-engineered and overthought, and I was excited to make it, but it was poorly done. I knew that, and so I ended up making a second version which was correct in that it was a simpler product. It's this threaded piece you see here. It would allow me to use either a hand hex key or even a torque gun and thread these in tight, and then I would put that in the vise and machine them. Worked better. There were a couple of problems with this. One is that the part would sometimes back out due to the cutting force of the tool, which would obviously cause a different cutting height, and worse off, it would sometimes chip your end mill. So that's amateur hour. That's no good. The other problem is it was just a pain to work with. It wouldn't hold at zero because every time you're reloading it, you're obviously moving it along your X in a different manner. And it wasn't accurate enough for me to do what I want to do with these, which is not only to cut these parts down, but also to chamfer the end. And on that note, this is the part we're working with right here. These are standard 3/8 inch shoulder bolts. They only come with 1/2 inch threads, and I want them to come with 1/4 inch long threads so that they can fasten into the rimfire steel targets that we make, but be flush to allow this spring to pass by without the stud getting in the way. I've priced out having these custom made with a shorter thread length, and it just doesn't make sense. You can buy shoulder bolts so cheap that are already ground and precise. It's better just to cut off the tops. So let's find a smarter way to do that. So the first thing we're going to do is we're going to grab a set of our Softjaws here. I've been buying these from Monster Jaws, and they have an eBay store, and they've been great. Great customer service, great quality, fast shipping, and I can't beat the price. I like these in particular because if you look at the oblong thread pocket for the socket head cap screw in your vise, these are reversible, which is a no-brainer to me. I can get two different fixtures out of the same set of Softjaws. So we've got the dimensions of these. Let's hop into SolidWorks and model these up. As we hop into SolidWorks, one of the things I wanted to talk about is why I bought it. I've had a ton of questions from folks, and to give a very brief background summary, when I started all this stuff, I started with software called Bobcat CAM. This is like 10 years ago, and it worked, it did the trick, but the software is kind of junky. They will negotiate heavily, so what they called a $3,000 software package, I literally think I paid like $180 for it. It's not parametric CAD, so the CAD is an absolute disaster. The CAM actually does function, so it was error prone, but it would work. But I was excited when I bought my Tormach to move on to what Tormach sold at the time, which was a Libre. They've since renamed it to Geomagic. It is, as I call it, a poor man's SolidWorks. It's a very similar interface and functionality. And then I did use and still do use SprutCAM for my CAM. So why did I move to SolidWorks? I had the chance to try it when I was working on a customer job, and I was somewhat cynical, thinking, you know, the features above and beyond a Libre aren't going to be things that are important to me. And then after about 2 days using it, I was blown away. It's the little things that you don't realize until you've had it, whether it's measuring or selecting edges or the way that the mates seem to be more intelligent in their selection and how they work together. And then there's the other things, which is so many of my customer jobs come in SolidWorks, and it's much nicer to say that's fine versus asking them to export it as an IGES or some other standard format. And then McMaster and GrabCAD, both great resources where in McMaster you can go download parts, and we'll take a look at the shoulder bolt we're going to work with right here. And not only is that part available, but if you want to learn SolidWorks, go find a part that McMaster sells that is similar to what you want, or just pick random parts and go walk through the design step. In fact, let's just go look at that right here for the shoulder bolt. So here we are on the McMaster page. We'll select the product we want, and you'll see product detail. And right here, you can download it as other formats, including IGES, but SolidWorks is better because I've downloaded this file and we'll hop into SolidWorks. And here it is. It actually lets you walk back through all of the design steps of the part. So literally, you can teach yourself how SolidWorks works by looking at, okay, so they extruded the top face, and then they are extruding the hex hole, and so forth, and then adding a plane, extruding the shaft, chamfering it, adding the threads right here, the relief. You can modify this part, you can do anything you want with it. There's no protection, if you will, to it. Adding the ribbed pattern around the circumference of the head, and so forth. So incredibly powerful to me, really cool. So happy to talk more about that, or if you guys even want to do a whole video on it. But today we're going to talk about Softjaws. So let's hop into them. I have already designed them, and you can see I've got a shoulder bolt here. I'm not using the one from McMaster, and the reason is it uses unnecessary computer and CAD horsepower to leave the threads and other parts shown. And it's just not necessary for what we're trying to do here. So you see I've modeled up a very, very quick shoulder bolt that's simply 3 different diameters, and we've got that in our set of Softjaws. Let's go ahead and open just one of these and take a closer look. So you can see the block itself starts as the dimensions of our Softjaws, and then what I did, which is a little bit backwards, was I extruded the whole shelf below. This is just how I thought about the part. I wasn't sure how I was going to handle the relief below, and I realized I want the head to set on a shelf. So you'll see here, there's where the shoulder of the shoulder bolt will set, and then I patterned that out, and then I added back the bottom half. What I should have done is just extruded out this little square here, but I thought you would at least this way see my design philosophy, whether it's good or bad. But this is better, and I'll show you why in a second. And then what we do on that last cut extrude is we want to, there's another great example, moving the part around in SolidWorks so much faster than a Libre. We want there to be some of the ability for the Softjaws to pinch the part, so we want this face here to be relieved off this face. So if you look, that's what that does, it just removes just a few thousandths there. Now these will be identical for both faces, so we only need one file, if you will. So I added them together in an assembly here, and if you look, as we zoom in, there's a slight amount of clearance. So we made this 255, so 5 thou extra. Technically the head would naturally rest against the bottom, not the top, as I've had the mates work here. But that's okay, you want the part to just go in with just a hair clearance. If there are any of you out there who aren't machinists, 5 thousandths is just a hair thicker than a piece of paper. Plenty good for the tolerances we're working with here. And then equally importantly, that face that I last extruded, cut away right here, creates this gap here that will let the Softjaws pinch against the ground face of the shoulder bolt itself. So they'll be securely held in, and they will be obviously maintain their X, Y, Z reference point, so I can do large batches of these without having to re-indicate or reset my zero. So let's cut these guys. We will hop into SprutCAM. The first cut we'll make, we'll have the jaw laid on its back, and we're going to cut this groove here with a 3/16 inch end mill, 5100 inches a minute, 10 inches a minute. We're going to take that in 6 steps. It's a little bit conservative, but not in a rush. And we definitely want to go over before we go down to avoid any sort of, to help the chips get out of there so you're not recutting them. That is an important strategy when you're going on deep, narrow slots like this. 3 thou finish only at the bottom level. We'll take a look and you get an idea of what that's going to do. Now, I had originally intended to face this down on this operation, but I decided to move that to the next op when we flip the jaws up, because it was easier to just choose this whole edge and have it be one continuous cut motion. So as we see, when we'll already have had our slot cut here, and this will rough a pass first, and then I think it's a couple depths, and then come in with the final here, like so. And it'll do a cleanup. It'll do a cleanup here on the end as well. There we go. Now, one little trick I like in SprutCAM is how do you select this edge right here? Sometimes, if you're lucky, it works better when you have curves and not 90s or hard intersections. You can double click a few parts and you can get it to kind of bulk select. In fact, maybe I just got it to work there. Holding down shift, it's not working. So here's how I select this top edge. I hit the button. If I view the front of the part, here, actually we'll delete it. We'll view the front of the part and we'll turn off everything except the edge. So drag a box around just the top here and you'll select all the edges that touch where you drug. Now hold down the Alt key and drag a box that is just shy of the top. Now you've removed everything except everything on the top, and now we can view the top side and hold down the Alt key again and drag a box here, and you've now selected that edge in, I think, a much quicker, more efficient manner. I like that trick. It can be really handy when you're working with complex parts. Okay, let's head over to the Tormach mill and cut these guys up. Okay, when we're actually using these, the slot would want to be on the inside edge here, so we're cutting that now. So we will drop our jaw in on a set of parallels. We'll grab our Heimer Zero Master here and come over and set our XYZ 0. Throw in our 2-flute 3/16 carbide end mill, and then let's rock and roll. I know this is a good feed and speed recipe, and I've used this end mill a lot with aluminum. You can see it is leaving a pretty solid burr along the cutting edge there. This end mill is probably on its last leg, and that's something that I've had to start getting adjusted to, is trying to account for end mill life, which can be difficult because you want to get the most use out of them and to run a profitable shop, but you also need to be holding accurate cuts and not being held hostage by not having a tool, say, even in stock. That gets even more complicated now that I've got a guy coming to help, and he runs the mill and I'm not always here, and that's been a great thing, but it means you've got to start paying attention to tool life and making sure you've got extras on hand and that you're maximizing the value out of that tool. We'll take a look though. That's one reason why I love doing the finish passes. My guess is that edge will be nice and clean when we run that 3/1000 skim cut or spring pass on the final depth. And if we take a look, sure enough, clean that edge right up. Okay, let's flip our part up. Like so. Parallels feel good. You could recess that further into the vise if you were worried about rigidity, but I can tell you it won't be a problem on this part. And we'll find our 0 again. You notice I always twist the TTS tool when I put it in. I found that if there happens to be a chip in there, it's easier to feel it if you rotate it a quarter turn or an eighth of a turn, and it's important to have a good mating surface there. I think it's always fun to try to get cool at different angles, so hopefully this turns out decent. I've got the camera actually cantilevered over a fair amount, so hopefully it doesn't vibrate too much. Okay, let's see what we got here. Grab our shoulder bolt. Perfect. Snug fit, no play or slop whatsoever. That should work out real nice. Let me go machine the second one, and I'll be right back. Okay, got the second one machined. Let's swap out our vice jaws. Thanks to Brad over Tactical Keychains. I know I've mentioned it before. I was watching one of his videos and what a great trick. Use a cordless drill with a 3/4 socket. And then I've got a torque driver. I've got on my to buy list a direct adapter version of this, but I had an extra hex key, the ball end, which you do want laying around, and you can back out your set screws just like so. Much easier way to swap out your jaws on the fly. Okay, let's load up some parts here and see how it goes. We're using a 4-flute carbide end mill, 2900 RPMs, 10.3 inches a minute. We're taking this in 2 depths of cut, so it's 125 thou depth and about the same width of cut. And then we're going to come in here with a 90-degree chamfer tool and make them real nice with a deburr chamfer. Okay, that, folks, is a winner. Here's an old version, if you will, and it was cut with that steel fixture, and it was an okay surface finish, but it came off with a sharp edge, which I then had to hand deburr on a belt grinder. And you can see sometimes what would happen is just like this one, where you would have the part rotate out, and it would both mar the finish and chip, or certainly very hard on an end mill, and the chip load on the end mill. That's the way the chip flutes. So our new version here is beautiful. You can see the quality of that cut finish. It's silky smooth. It's already deburred. If we grab a nut, it will thread right on. No problems at all. That, folks, is exactly what we were looking for. So I'm very pleased with that. I really love Softjaws. You saw I had a whole drawer of them because they're not expensive. You can machine them down for other jobs if you're done with the job, and they're such a good way to fixture it. I talked about what's the takeaway from any Wednesday widget, and today's takeaway is, think and do it right. Don't be scared to invest. I think those Softjaws are like $11 a set, and you can obviously flip them over, so it's $5 per side, and you can even reuse them. So the money is nothing compared to your time and doing a job correctly. And any machinist worth their salt will tell you that machining something isn't too hard. It's usually the fixturing that requires a little bit of thinking, and I'm a little embarrassed to say it took me a few tries to get this one right, but I'm very, very happy. This new one is safe. It will promote tool life. It'll give a higher quality cut finish, and it's just a win all around. So folks, if you have enjoyed this, if you have liked this, please give me a thumbs up, comment, share, all that good stuff. Otherwise, I'll see you next Wednesday, if not sooner. Thanks, folks.